Hello, in this video I'm going to go over a previous question from a few years back before the new spec, but it's appropriate for the new OCR A spec involving non-parametric tests. This one's a Wilcoxon paired signed rank test, and there's a nice little intro bit where it's asking us why we would do a paired test. I'll probably answer that first, but I suppose we need to look at the data. It's about a booster campaign and the effectiveness of a booster campaign before and after some publicity is kind of undertaken. And so if you look at them, most of them, not all of them, have increased. And that's what the hypothesis is as well. It's a one-tailed test on it being increased. Most of them have. They haven't all. For example, B hasn't increased, but C has. D's decreased, E's decreased, but F has increased, G has increased, H has increased, and I has increased. So, most of them have increased, a few have decreased a bit. And the question is, how effective is this publicity campaign? And it's a paired sample because, of course, we've got the same, we're looking at a particular local authority here that a particular local authority, and we're looking at what's happening before and after the campaign for that local authority. So it is a better test when we can pair, because what happens then is it will eliminate differences between the local authorities themselves. So that's our first question. Why a paired test in this context? So eliminates differences between the local authorities themselves. Let's say the particular local authorities. Because we've paired them, if one particular authority is particularly prone to be, where the booster campaign is not very high take up, and that particular authority it finds it difficult in some way, that difference is accounted for by the fact that we've paired the data. So any variation between the authorities themselves is kind of eradicated, or at least reduced, as a result of pairing. Okay, so if you get a question on that, you need to actually refer to kind of you need to give a contextual answer similar to that for whatever question it is. It's because any differences within the data themselves will be eradicated or reduced at least, so it will eliminate it. So right, that's the first bit. Now let's get on with the test. How to set it up. I tend to like to use symbols. I think we can use symbols, but we must make sure that we define what the symbols are. So MD is equal to 0, and H1 MD now it's one-tailed and it's increased. So MD is greater than 1. Is greater than 0. So MD equals 0, MD is greater than 0, where MD is the population median difference. Median difference between booster. Well, there's a question. Campaigns between booster induction take up before and after campaign. Before and after campaign. Okay, So let's now actually do the calculations and compare with the tables. So if we do that, so let's work out the differences first. So the difference here, it's increased by 6. Then here it's actually gone down by 1. Here it's increased by 5. Here it's decreased by 4. Here it's decreased by 3. Here it's gone up by 11. Here it's gone up by 8. Here it's gone up by 2. And here it's gone up by 9. So those are the differences. So then what we do is we find the rank of differences. And what I tend to like to do here is to first of all just rank them, ignoring the negative sign, and then put the negative sign on afterwards. Let's change the colour. So the smallest is this one here, so that's 1 in magnitude. The next smallest one is the 2 here, so that's 2. Then there's only a difference of 3 here. There's a difference of 4 here. A difference of 5, 6, and there's a difference of 7 here, 8 here, and 9 here. So now what I'm going to do is kind of like re-establish the sign after finding them how far they are basically from each other first of all, ignoring the negative sign, ranking them in terms of magnitude. Now let's preserve the negative with them. So rank of differences, or I'll put signed rank of differences because that's what we're doing, isn't it? Rank of differences is not taking account of the negative, and then the signed rank is when we attach a sign to it. So that's -1 and -4. Okay, so then we work out the two, and we can actually go to the formula book here. Basically we find the positive we find the sum of the positive differences and the sum of the negative differences, and take the least one of those two. So I probably would do both of them, but clearly the negative one is going to be smaller. But I think you never quite know what examiner is going to expect us to do, so I don't think it's worth trying to dice with the situation too much on this. So we work both of them out and go for the smallest one. Okay, so let's do the W plus first. That's equal to the 2 plus 3 oh, so I just noticed I've missed out a negative signed rank there. The -3 there. So working out the positive ones first, that's 6 plus 5 plus 9 plus 7 plus 2 plus 8, and if you add those up you get 37. And then W minus, that's the kind of the negative ones added together, and then we can modulate at the end. -1 -4 -3, that's equal to 8. So that's our test statistic. So test statistic is the smaller of these, so that's 8. So it's the smaller of W plus and W minus. Okay, and then we need to check that from the tables. Now we've got n equals to 9 here, so we need to find a critical value. And the significance level, which says in the question, is 5%. I think it says that somewhere. Yeah, 5%, and one-tailed. So we're doing 5% one-tailed with n equal to 9. Let's look for that number in the tables. N equals to 9. 5, we've got the test statistic, the critical value is equal to 8. Okay, so the critical value equals to 8. So we've got, it was also equal to 8. So we've got test statistic equals to 8 equals to critical value, which is also equal to 8. So that means we have sufficient evidence. So we reject H0. And now we need to actually have a statement which has some level of uncertainty in it, and also has some nod to the kind of the actual context of the question. So there is sufficient evidence to suggest take-up of the vaccine is increased as a result of the campaign. Okay, that's it. Okay, so we put I suppose in some ways, although it's only 1 mark, the really fundamental thing is that the Wilcoxon signed rank test here, paired, is the way to go, because pairing is appropriate here because it's the same local authority, which then makes it a better test because it eliminates any differences between the authorities themselves. Okay, let's leave it at that, and I hope you found this in some way useful. Goodbye.